Thank you all for coming to Debugging Apache Spark, also known as Professional Stack Trace Reading. I'm Holden, and this is Joey. We also have Boo, and we have a new friend with us who isn't super certain on their name yet, but we're working on it. Stuffed animals are a very important part of learning how to debug Apache Spark. Is the microphone not working out so well? Okay, how about this? Does it work if I just talk into my chest? Okay, that's weird. So yeah, my name is Holden. My preferred pronouns are she or her. I'm a developer advocate at Google as of this month, or last month. I'm a little fuzzy on that. It's December. Okay, last month. I am a Spark committer as of early this year, and I've worked at a bunch of other places on many similar problems, mostly working with Apache Spark, but also sometimes similar systems. I'm a co-author of Learning Spark and High Performance Spark. I got a much better royalty deal on High Performance Spark, so that book is much better. Gives me about a quarter of a cup of coffee in San Francisco. And you know, coffee's expensive. You can follow me on Twitter, and the slides will go on SlideShare as well. Outside of work, I'm trans, I'm queer, I'm Canadian, and I'm part of the leather community. And this might not seem like particularly related to Spark, and it's not, but I think it's just useful to remember that we all come from different places. We all have different backgrounds, and if we work together, we can get through this terrible shit that is writing distributed systems faster. We all get out of memory exceptions, and this kind of sucks. There's no secret Canadian decoder ring that we've been hiding from you, I promise. And yeah, Boo uses she, her pronouns as well, and she is the best Doge. She's the author of Learning to Bark and High Performance Barking. Unfortunately, I wasn't able to bring copies of her book with me. They're still hand-drawn, so it's limited quantities. Joey was going to do himself.
Yes. I'm Joey Echeverria. I use he and him pronouns. I work on stream processing problems at Splunk. That's not my actual title. My title doesn't make any sense, so I just make one up. Previously, I was at Rocana, and before that, I was at Cloudera, working on big data stuff, which I don't think is a buzzword anymore. I think now I'm supposed to use machine learning or possibly AI. I'm not sure which. Mostly, I have a lot of experience feeling the pain of distributed systems, and I want to share my tips for relieving some of that pain with you. I did write a book called Hadoop Security. This was released many years ago, so no one cares about it anymore. But if you want your Hadoop to be more secure, you can buy that book. You can find me on Twitter if you want to. I mostly post about politics and a little bit about tech, so I apologize in advance. And I'm on GitHub because you have to be. Who are you? Oh, I guess I'll have to answer that. We think that you're friendly people. We don't think that you mind cats or stuffed animals. If you do, probably not the right talk for you. You hopefully know a little bit of Spark. Otherwise, you shouldn't be debugging it, and you should go to your boss and get them to teach you Spark first. Probably you want to debug your Spark applications because they probably don't work. I mean, because you're in the talk, not because they're Spark applications. And things are going to be very serious and stoic from here on out. So we're going to talk about logs, because everybody loves to hate logs. You're going to have very many options for logging, and they're all going to be painful. We're going to try to help you understand some common Spark error messages, because there are common Spark error messages. We're going to let you, or teach you how to read DAGs. It's very important for you to understand what your application is actually trying to do, or rather what Spark is trying to do with your application to make it easier to debug. We're going to very subtly try to get you to adopt Spark Testing Base, which is a testing library for Spark. Teach you some fancy Java debugging tools that work with remote clusters. Not entirely sad, but a little sad. Holden is going to even less subtly attempt to get you to buy her book, especially High Performance Spark, which I understand is better because it pays higher royalties. And there will be plenty of pictures of cats and stuffed animals. So this is the only slide that I've prepared to give because it's naming the stuffed animals, and I will attempt not to get it wrong. First of all, on the far right, there's the newest member of the team, who for now we're calling Toki. Toki is a municorn, which is a mermaid/unicorn. Toki represents when you have a Java stack trace and Python stack trace together, because everybody loves reading two stack traces at the same time. If you prefer to separate your stack traces, you can talk to Boo. Boo is going to be your Python worker stack trace, Python exclusively. If you're more of a JVM type person, you can talk to Friend Monster. Friend Monster's in green and will be your JVM stack traces. Everybody's favorite error is Tubbs, who is an out-of-memory error, which is great because out-of-memory errors have a history of hitting not in the part of the code that actually causes the error, but some random part of code when you just wanted to allocate a stupid object. And then, of course, in order to read all of these lovely stack traces, you're going to need Spark's logging system, which is represented by Buddy, a very small yappy dog. And I think I got those right. Excellent.
100%.
It's all downhill from here. So where are you going to get all of these lovely logs and errors? Well, the great answer is it depends. So you're going to have to know sort of how you're launching your application to know where to look. If you're launching in client mode, error messages are often reported to the console. Same thing with log messages. Log messages specifically from the workers, you're going to access via the Spark web UI. Or if you're using Yarn or another cluster manager through the Spark history server. Another important thing to consider is that sometimes error messages will be produced by the driver code, and sometimes they'll be produced by the worker code. The easiest way to predict which is if you're actually processing data or doing something with data, it's probably going to be in the worker rather than in the driver, unless you're really lucky. Now, I've told you roughly where to look for logs, but I actually don't want you to look for those logs yet. The minute that you get an error, the very first error that you see, what I actually want you to do is take a step back, sort of picture in your head, or maybe draw it on a whiteboard, or on a piece of paper, or on a computer, how you think Spark should be dealing with your program, how it should actually be implementing your application. If you need to, take a look at Spark's visual DAGs. We're going to be talking a little bit more about that later. And really think about, okay, based on how I expect this program to work, where could this error be happening? Sort of where in this architectural picture could things be going awry? The reason why I want you to do that is that means that instead of just having to read logs and sort of divine what they mean, you're going to be able to fit those logs into a pre-existing theory or narrative. And what you're going to do is, instead of just reading the logs straight down, you're going to say, okay, if I think the error is here, what would I expect the first log error message to be? And where would I expect it to be? Then you're going to look for that. And if you don't find it, you're going to say, okay, maybe my theory was wrong. And if you do find it, you're like, okay, I'm on the right track, let me keep going. The reason why you want to do that is because log messages often make very little sense. Log messages tend to include whatever the developer of the library or application thought you might want to know, rather than what you actually want to know. So if you have a rough idea of what you're looking for before you start reading them, you can ignore all of the log messages that are debug temporary message versus the errors that you actually care about. Of course, you probably will be working with Yarn or some other cluster manager, so that introduces new and exciting challenges when looking at logs. You can use the yarn logs command to get logs on the command line. That doesn't always work, so sometimes you have to go to the Spark history server, and you can access your logs that way. Very helpfully, Yarn likes to delete all of the application logs after your program finishes, because whoever wants to look at logs after the application is done. But you can actually fix this. There's a configuration parameter for your node managers called delete debug delay seconds. It defaults to 0, so probably you don't want that to be 0 because if an application fails, you want to actually look at those logs. So set that up to like 5 minutes, 10 minutes, or maybe even longer if you've got plenty of space to store your yarn worker logs. That way, after your application fails, you can still go back, look at what happened, and figure out why it failed, and hopefully fix it from failing in the future. Spark is very verbose by default. You're welcome. Most of the time, it will tell you a lot of things that you don't care about, or things that you just don't need to know. So you do have some level of control of this. Programmatically, you can actually use the Spark context to set the logging level. So that's very helpful if you want to dial up the logging level very close to where an error is happening in your program, or dial it back down in other parts of your program that appear to be working fine. And with that, I think I'm going to hand it over to Holden to talk about where these lovely monsters will pop up.
Lovely. So, thank you. I'm going to try this side of the room so that we can look at these fine people too, but my microphone doesn't seem to be working. Maybe it is. Okay, whatever. So what about when we get an error, and where will these error messages come from? Python Spark errors often come in 2 parts. You tend to get a Python stack trace along with a Java stack trace, so you get the Mernicorn. JVM stack traces normally will come along with whatever error message you've got. Normally what will happen is you'll get an error message from your worker program wrapped inside of another helpful, pretty much useless error message from the driver program, just reporting that it found an error on the worker. Python people, Boo has the information, and Buddy is our lovely person who just tells us what's going on. So JVM stack traces in Spark are pretty normal. The part which is different is if you get an error from a worker, you'll end up getting this error from the worker wrapped in an error from the driver, and this can be a little bit confusing because you might think there's an error in your driver code, but almost certainly most of the times when you get those error messages, it's actually something happening on your worker. If you're working in Scala, the stack traces may not be super readable, especially if you're using lambdas, so Joey will talk about lambdas in a little bit. For R and Python users, it's pretty much the same thing as above, except it's a little easier to tell when your error message, which part you care about. You probably don't care about the Java part, and you probably care about the Python part or R part, respectively. It's not always true. The other one is when we get our JVM stack traces, we can also get many copies of them, which is delightful. So one of the wonderful things about distributed systems is when they fail, they tend to not just fail on one machine. We can have all of our cluster nodes fail at the same time. Yay! And so I can get 100 stack traces with roughly the same information, but just in case it's different, it'll give me 100 copies. And that's just real useful when it comes to figuring out what's going on. So we're going to make the simplest mistake that I could think of. And we're going to look at how to debug dividing by 0. Very exciting. So in Scala, we can have some input data. We divide it by 0, and then we force the evaluation. And this gives us a wonderful 100-line stack trace. For 3 lines of code, that's just super reasonable. And so part of this is that we might have several executors dividing by 0 at the same time. Spark also doesn't know if the division by 0 is a deterministic failure, so it'll run it again on a second machine, just in case the other machine is able to divide by 0. Generally speaking, hasn't worked out for me yet, but I appreciate Spark's gung-ho attitude. But the nice part is, if you get this error message, it's pretty clear what's going on. We've divided by 0. It says so right at the top. I'm pretty good. I know I can just ignore the extra 30 copies of this error message. We can do the same thing in Python, and then this takes our wonderful 100-line error message and turns it into a 400-line error message. Yay! Okay, people are laughing. That's good. And the wonderful thing is, you may notice, although the text is way too small, but you can trust me on this, nowhere in this text does it say anything about dividing by 0. Jazz hands. And so this is delightful. And it turns out that if you dig through this enough, you can find the part where it says it's divided by 0, but it's not like the Java exception where it's pretty clear what's happened. It's right at the top, and I can just read that. In Python, it's buried in this wonderful sort of, it's like a turducken made of stack traces. And so we have to go and find the innermost part of the turducken. And so we're going to do that. Does anyone work in Jupyter or other related things? Okay, lovely. I want to share a quote with you that I got. The error messages were so useless. I looked up how to disable error reporting in Jupyter. And I'm seeing a lot of nodding faces, or heads, whatever. And this is because you can see, you can get an error message reported in Jupyter when you run some invalid code. But the really lovely part is, the error message that gets bubbled up only contains the useless parts. So 100% of the useful information is discarded before it gets to Jupyter. Now I have a pull request to fix this that I've forgotten to update for 8 months. And unfortunately it's because it doesn't work in PyPy, not PyPy, whatever. There's one interpreter it doesn't work in, and I got lazy. But it's okay. Instead, we can look at this part. So when something goes wrong in Jupyter, you just go into the terminal where you launched your Jupyter notebook from, which of course we're all used to doing, minor sarcasm, and then we can see, oh, actually, yeah, it looks like ends with isn't an attribute on the Unicode object. Okay, that's what my actual error message was. And this is great and lovely, except sometimes we use these things called hosted solutions. And the problem about hosted solutions is that I don't have a console to go to. Or someone does, but that person is not me. And normally that's a much better trade-off because that person has a pager and I don't. But sometimes the person with the pager has information. So if you don't find a place to find this information in your hosted solution, you can sometimes find it in the Spark web UI instead. Alternatively, contact your hosted solution provider and ask them to fix this bug. There's a PR that I have that they can update and finish, or not. But it's okay. So let's say that we're going to go and use the web UI because I want something that works today. So I can see I have this very exciting stage 0. It has one task in it, and it did not do very well. So I see there's this failed task information. You can't read the text, but I assure you it is useless. And so we just go and we click on it, because maybe if I click on a thing, it'll have more information for me. And it's true, it has more information for me. Once again, none of it is useful, but there's more of it, and that's what counts. This is also why I eat at McDonald's. Well, sorry, I love McDonald's, like non-facetiously, like. Long story. And Slurpees. But anyways, so this contains neither a McChicken sandwich or a Slurpee. So we have to go further and to find our actual error message. So we can apply the technique of scroll not quite to the bottom, which is a wonderful heuristic. And then we can find what is probably our Python exception. And here, yay, integer division or modulo by 0. That was, okay. That's our error message. Admittedly, this is probably not really what you want to do. You probably don't want something which is scroll most of the way to the bottom when you get an error message on the 3rd page of your driver details. But that's sort of where we're at. The other option is you can search for this magic string of org.apache. Oh, fuck. I'm going to come over here and read it. Search for the magic string org.apache.spark.api.python.python exception : and this will lead you to the innermost Python exception that happened on the worker. And this is normally the Python exception that you want. And so this is useful, and you can find your actual error message inside of your code. We can do the same thing in the console logs if we are not working in a hosted cloud environment. And right, Scala, same thing. Okay, so let's talk about Spark's DAGs. And it's not DAGs as in dogs, but it's DAGs as in directed acyclic graphs, also known as maybe I want to publish a paper and sound fancy. I did not go to grad school, so I have some opinions about that. But we can see here there's actually 2 very different versions of the DAG, depending on if we're working in Python or Scala. And for those of you who have worked in Python before, you can probably guess that the Python one is useless. And so here, essentially, we can see if we're working in Python, the information that I get is I have a thing, and then I did a thing. But there's not a lot of information about either the thing that I have or the thing that I did. But it tells me that something happened. Admittedly, we probably could have figured that out because it threw an exception. In Scala, admittedly, we have a thing, and then I applied map to it twice. Once again, not super useful, but a little more useful. This gives us an idea of these are the different things that are involved in the thing which has exploded. And so I can narrow it down to probably being in one of these three things in the Scala code. In Python land, I don't really get that. And it's a little unfortunate. And this is because we do some really terrible things to try and get halfway decent performance out of the Frankenstein monster that is the JVM and Python combined together in one execution stage. And so essentially, because copying data is really expensive, although Apache Arrow is our savior from this, and that is another talk, we try and put all of our computation together inside of Python when we can, and sort of limit the number of copies happening back and forth between Python and Java. And this is great for performance, but terrible for debugging. So one of the things that you can do when you're working in Python is sort of accept that your performance is not going to be great during your debugging experience and just sort of break this functionality. And so you can do this by marking the intermediate steps as things that need to be persisted. And then what happens is Spark will evaluate each of these individual map statements on its own, take the result, copy it into Java, save it in memory, and go and compute the next one. And this will completely destroy your cache, but it does force each step to get evaluated one at a time, so you can figure out what is actually exploding. The only downside is if things are exploding because something weird is happening in your cache. Now we just broke that for you, and yeah, well, good luck. But this can help a lot of the times, because most of the errors that we get don't come from interactions with Spark's cache. Not all. The other option, of course, is take one and count. Take one will force evaluation of just this individual record. It's useful. It is not always going to work for you because Spark is very lazy, much like a teenager. And if you call take one, Spark will only evaluate one of the partitions. And it's possible that you have an error which only shows up on some of your data. And so take one won't actually trigger the error. But if you have like something like our divide by zero case, take one will do a very good job of exposing that. And then you don't have to cache all of your intermediate states either. Joey's going to talk about why lambdas are terrible.
Yes. My agreement with Holden for co-presenting with her is that I get to talk about lambdas because I have been burned by lambdas many times, and so I thus have very strong feelings about lambdas. Lambdas are great. Don't get me wrong. Everybody loves the syntactic sugar. Everybody loves the fact that your code can be so tight and compact until you get an error inside of an anonymous function inside of a lambda that is like 3 deep in a series of lambdas. So I'm begging you, go ahead and use lambdas, but the first time that you debug an error related to a lambda, just pull the lambda out, give it a name. Clearly this is a function that you want to love. It's like a pet, right? Lambdas are like goldfish. If they're going to die, you're okay. You want your functions to be like, I mean, not great, but it's not as bad. It's not as bad. Functions are like cats and dogs. Okay. You give them a name. You love them. You care for them. You write tests for them. Maybe. Somebody writes tests for them. And I'm going to be perfectly honest. A little bit of refactoring in order to increase the debuggability of your code has never caused a problem. Okay, you really shouldn't listen to me. That was a blatant lie. But usually the potential problems that it causes is not as severe as the pain of getting an exception on an anonymous line of a console that you don't know where on earth it actually is. The other thing is, truly, if your inner functions are where you're getting error messages and exceptions thrown, you probably want to unit test them, so you probably want to pull them out and name them. I'm not going to tell you that you have to write tests for everything all of the time. because usually all that does is increase like the line coverage chart in some Jenkins somewhere. But when you know that a particular line is causing problems or a particular function is causing problems, probably try to write some unit tests for it. The other problem with lambdas is it's a little bit harder to put logging messages inside. So if you wanted to take advantage of Buddy, you're not going to be able to do that as easily if you're still using lambdas. So again, testing is something you should absolutely 100% do. Some of you may notice that Holden has given me some side eye, and that's because the last time that we gave this talk together, I revealed on stage for the very first time that this wonderful library that Holden had made, I had taken some of the ideas for it, forked it, as one does with open source, and not contributed those changes back.
I'm like, come on, we talk on the same stage, man. Like, just give me your fucking code. Or lovely code.
Yes. Now, this was very rude of me to do, but this was like 8 months ago. And helpfully, since that time, I have still not contributed that code back to her project.
I actually had to write that functionality.
Oh, that's my bad. That's totally my fault. Good news is, though, Holden added that functionality, which was basically extending the library to work with streaming applications. But the cool thing is you can pull this from pip and from Maven Central. There's also a link in the slides that you'll be able to access when they're on SlideShare that takes you to the GitHub project. You should submit PRs. Don't be like me. You should submit PRs if there's functionality you want to add to it. Going deeper into testing Spark, Holden actually has a complete other talk that she's given on this, and you should for sure check that out on YouTube. You probably also want to add your own logging as you go through. If you're using Java or Scala, Log4j and sort of related logging libraries are your friends. If you're using Python, you can use Python's built-in logging library, or maybe just print. It's probably good enough. This isn't being recorded, right? Okay, we're good.
I think there's a camera.
Oh, definitely use a logging library. Accumulators can also be very helpful. Note though, accumulators can behave very weirdly. You don't want to put a lot of data into them. Definitely don't use accumulators to try to like calculate what your program is doing. But in terms of like getting information about how things are trending or rates of different things, they're very useful for that. This is another favorite topic of mine, which is not every error is like divide by 0. Not every error is going to hit every single time that you try it. Very often, actually probably most of the Spark code that you're writing is actually just parsing something. You're probably trying to take some piece of data, convert it into a new format so that eventually you can apply your fancy ML algorithms to it. All of that parsing means that you have to deal with bad data. So what are you going to do with malformed records? Using flat map can be your friend. Using filter plus map can also be useful for this. But you really want some way of tracking rejected records. Another thing that you can do is, especially if you're doing the filter plus map trick, is you can take those rejected records and you can send them somewhere. Because while it's great that you can make rejected records not blow up your program, probably you want to do something with that data. You want to know why it was rejected. You want to give that data some care and feeding. And so to do that, you want to persist it somewhere. You can just log it. I can tell you that if you log rejected records, no one will ever read those logs and no one will ever fix that data. So hopefully that data wasn't actually important. But in case it was, you can use dead letter queues. An easy way to do that is instead of logging the message to a logging library, log the message to Apache Kafka or any other log collection tool that you're using. So what would an application look like if we added some accumulators and logging? It would look more like this. So we would actually take your function, it's no longer a lambda. We would give it a name. We would throw in some exception handling. We would log the error message that we found, and we would count it. So that way you can use the accumulator to tell you, okay, how many of these records are getting rejected? And again, logging isn't the best, but if you're saving it at least somewhere, you have an opportunity of looking at it again. And then the other thing that we do is at the very end, we're going to log the actual accumulator value so that we can see, okay, how many of these actually failed. For any astute programmers in the room, all of them will fail for this particular example. What about running out of memory? This is where we come to our good friend tubs. So memory errors typically happen in the middle of a Java stack trace. They typically don't tell you where you're running out of memory. The actual cause of your memory bug is probably in some other piece of code. But we're going to tell you about it now because this is what I finally hit the limit. Tubs doesn't always look the same. You're going to get many different variants of an out-of-memory error. It can be purely in the JVM worker. That can happen if you're trying to do a very large join. You can get GC time limit exceeded, which is everybody's favorite. I didn't technically run out of memory, but I spent so much time not running out of memory that I ran out of memory. You can also get true out-of-memory errors. You can get executors being killed by the kernel. The Linux killer can come in and just hopefully destroy your worker. If you're running in Yarn, you'll oftentimes see application overhead exceeded. That's kind of similar to the GC time limit exceeded. The JVM can get out of memory on the driver side when you're working with Py4j. Lots of different places where you can run out of memory. So the reasons why you'll get JVM out of memory errors when working with PySpark: you can get unbalanced shuffles. This is probably the most common. You may think that what you're doing isn't going to use a lot of memory, except that someone helpfully modified your data so that everything maps to the same key now, rather than to a wide variety of keys. You also get to deal with fun things such as buffering rows, especially if you're working with PySpark and UDFs. Again, trying to be faster and more efficient. We're going to buffer a bunch of things together, and now suddenly you've run out of memory. You can also end up with individual jumbo records. If you're using Python's pickling, which is a way of serializing Python objects to byte streams and vice versa, sometimes just a really giant record that somehow got inserted into your data stream can blow everything up. It's also great because you can run out of very different types of memory. It may not always be JVM on-heap memory. It could be off-heap storage. And we work in these lovely protected memory languages, which means that, of course, you can have a native code memory leak. And I think Holden is going to take over for the rest.
Rockin'. How are we doing on time? Okay, we're good. So the Python workers will out of memory for many of the same reasons that the Java ones will, except a little bit differently. One of the really unique causes with Python is insufficient memories reserved for the Python worker itself. And fundamentally what this comes down to is Spark divides the memory in the application containers that it's assigned between Java and not Java. And by default, it gives 90% of everything to Java and 10% of everything to not Java. And this is fine if you're writing Java code, but when you're writing Python code, this means that your Python code has 10% of the memory to actually execute in. This is not useful. So fundamentally what will happen is your Python code will try and even just read in the few records that you've given to it, run out of memory, and fall over. Delightfully, you can tell Spark that, hey, I'm running Python code. Please don't do that. And you do this by tuning this helpfully named parameter, yarn.applicationMemoryOverhead. And you just sort of tune that number up until your job starts working, add 5 to it, and move on. 5, yeah, I know, counting. Sorry, friend. Friend is a strong word. Sorry, it's been a long flight. Right, and so essentially this is a configuration parameter which most people set empirically, also known as guessing. Jumbo records, definitely an issue in Python. as with Scala, this tends to happen when we accidentally serialize things that we didn't think were serializing. So often we'll have a class, and the class will have some things inside of it. We'll make a reference to something inside of the class, and then we forget that our serializer is kind of not really well-intentioned. And our well-intentioned serializer says, well, you reference this thing in this class. Maybe you need something else in this class. I'm just going to take everything and put it in there. And that's fine, unless your class contains like a connection to the database and maybe like, all of the other records. And then, maybe you run out of memory. Maybe not. Maybe your job just runs really slowly. I think that's the best case, but I'm not sure. The other option is too large partitions. This can happen especially commonly in Python because our method for partitioning technically works. Yeah, that works real well. Fundamentally, it depends largely on you having a good hash function for your key classes. And in Python, that's not a thing that tends to be as important as in Java. So oftentimes classes will not have a great hash function. The other wonderful thing is we have to disable a bunch of hashing improvements that happened in Python 3. So that just makes your code extra performant. And so you'll probably want to write a custom hash function if you see some weird shit happening. My favorite error message in Spark is actually a Hadoop error message. And it is the error message that we get when we load an invalid path. And I like this one because it tells me what happened. And it doesn't tell me too much other stuff. This error message notably fits on a screen. And I tend to get one copy of it. And it's org.apache.hadoop.mapreduce.invalid input exception. Input path does not exist. And so I wanted to end on like a happy-ish note. And so if you get this error message, what happened is the input path does not exist. Alternatively, the other reason that you can get this error message is your Hadoop security fucked up by Joey's book, or a Cloudera support contract if you're using Kerberos. Good luck. The other one is you forgot to connect to an HDFS cluster. Good luck. And that's pretty much the two causes of this one. So let's focus on happy things, debuggers, yay! So debugging Spark is not all just staring at stack traces and drinking. Sometimes it is telling an individual worker to wait until I've had a chance to grab my favorite iced tea, or beverage of choice. Slurpees. Slurpee. Oh my god, I love Slurpees. Relatedly, if anyone knows a place with 4 flavor Slurpee machines that is nearby, let me know. My adventures to the 7-Eleven have not panned out. But back to Java debugging. We can connect a remote Java debuggers. These are wonderful and amazing. You have to specify some extra options to actually enable it on your workers. You can tell it to wait for you to connect a debugger first before it starts working. This is really useful if your job fails immediately. This is not so useful if your job involves many machines, because then you have to connect a debugger to each machine. So generally, I don't enable suspend equals y. I just press buttons really quickly and hope I catch the error message before it goes boom. And honestly, most of programming is hoping. So that's fine. If you have like fancy IDEs, they can normally talk to this protocol. It's great. Most likely, you will have to change your firewall rules or enable a tunnel because people don't seem to like it when I connect debuggers to a production cluster. For Python debuggers, it's roughly the same story except sadness. So you can connect debuggers, except there's no like built-in flag to enable the debugger. Instead, you take this pile of code that you can find on my GitHub, and you shove it at the start of your program. And what it does is it makes a broadcast variable, and essentially it asks all of the workers to, hey, please start a debugger for me when I reference this variable. And then it starts a remote debugging library, and you can connect to it. And it sort of works well enough unless your code failed because of broadcast variables, in which case, no, you can't have a debugger. The other wonderful thing is just because Python is known for the one way to do it, there's several options. And pick the one that you like. Pick the one that works with your tool train. The alternative approaches is we've mostly talked about how to debug sort of in a cluster. And I think it's really important to remember that a lot of times, if our failures are deterministic, we don't have to debug in a cluster. We can just sample our data and run it in local mode. And if you can get your error message to reproduce in local mode, you don't have to worry about most of the shit we spent the last of the talk talking about. We had to save this for the end so you didn't just leave. But sampling your data, running it in local mode is a really good thing to do when you're like, what the hell is happening with my cluster? The web UI, it's useful if you're in Scala. It's less useful if you're in Python. Okay. Oh, the slide is out of date. Let's move right beyond that. So this is the most important one. High Performance Spark is available today. You can buy it from Amazon and help support Jeff Bezos purchasing another newspaper and myself purchasing another quarter of a cup of coffee in San Francisco. If you don't have a corporate expense account, you can come to a book signing at the O'Reilly booth. There will be 25 free copies, but I really encourage you to buy additional copies with your corporate expense account. Cats love the box that it comes in, and I assure you, cats get upset when you return the book that came in the box. So you definitely should buy this book. I don't think people are going to buy the book, Joey.
I think you should buy the book.
Okay, look, unbiased opinion from the person standing within striking distance.
Yes.
Okay, I have a meetup tomorrow somewhere in Singapore. I'm not sure what I'm talking about or where it is, but I'm pretty sure it's related to distributed systems or machine learning. And I really hope it's in Singapore, or I have to book a flight later on today. I don't know. If you go ask the people at the Google booth, I think they know where I'm talking tomorrow, because that was really my plan for figuring out where I was going. I will be in London next week, also Berlin. If anyone wants to go to cold places, I don't know. If you like snow, come to Berlin. If you want an excuse to go to Sydney, did we update this one?
I fixed it.
Okay, Joey fixed this one. I said Melbourne yesterday, I got the city wrong. If you want to come to Australia, I'll be talking about open source communities at LinuxConf Australia. We'll probably be talking at Strata San Jose, because why not? I mean, unless you all tell the O'Reilly people that this talk was terrible, so don't do that.
Yeah.
We like traveling on our employer's dime. Oh, we forgot to mention that Tokidoki was paid for by my employer.
Yeah, we should mention it now.
I would like to thank my employer, in anticipation of them accepting my expense report, for our new stuffed animal, who is very clearly a key part of this presentation in explaining distributed systems, and therefore a legitimate business expense. I really hope my boss watches this talk and approves my expense report. Okay, that's pretty much it. I mean, we can do some more shitty jokes, or we can answer questions. I don't know how much time we have left.
Quick question.
Yay, questions!
Right, so I think the last slide answered the question in some ways. I was alluding to the point.
This
that
one?
Instead of getting straight on the cluster, develop it on a pseudo cluster.
Yeah.
But the corollary is, if you get no concern in your pseudo cluster, can you take it as a guarantee that it will throughout?
Oh dear God, no. No. If you get no bugs in your local mode, like fake cluster, that's good, but that is not good enough to know that it will actually work in production. There's a lot of things that really only happen in big clusters. Essentially, like, it's difficult to simulate key skew in local mode because all of my data had to fit in memory anyways for local mode, and so I won't notice the key skew effects. The other one is there can be some really weird behaviors with empty partitions and things like this, which, while you can make happen in local mode, tend to happen more frequently in the real distributed mode. So just because it works in local mode is not a guarantee it will work in prod. But if you run into a problem in prod, debug it first in local mode, because if it shows up in local mode, it's a lot easier to debug.
Are there recommendations on how to set up a production cluster?
That's a lovely question. So are there recommendations on how to set up a production cluster? Coincidentally, my employer sells a service to set up a production cluster. And I don't know if I should. I haven't used it, but I'm sure it's very good. We have some delightful demos, and they look quite impressive. I would recommend that you buy whatever it is we're selling. If you don't want to do that, does your employer sell anything?
Not Spark related, really.
I have some friends at Cloudera too, if you want to buy their stuff. They're nice people. Really, if you want to set up a production cluster, I think the cloud is a really good way to do it. There's hosted solutions from both my employer and then other people who do not pay for my stuffed animals, so they don't get as much of a mention, but they're good people too. And they do pretty good managed clusters as well. Thank you for asking a question to make it more likely my expense report will be approved. So I think that's it. If anyone wants to come to the book signing at 3:15, I can answer your questions in person. Otherwise,
and I'll be around.
Joey will be around. If anyone wants to get Slurpees with us, come find me. I am always up for more Slurpees. Thank you.
Thanks, everyone.